Intro. Since its launch in late 2021, the James Webb Space Telescope has unveiled wonders that redefine the cosmos. But now a seismic shift has occurred. The pinnacle of human ingenuity in astronomy has just captured phenomena so baffling, so defiant of established laws, that physicists are declaring a rupture in our foundational knowledge. From enigmatic objects that rewrite the dawn of galaxies to interstellar visitors bearing secrets of alien origins, Webb's revelations have demolished the boundaries of accepted science. What if the universe's infancy was far more chaotic and advanced than any model predicted? Remain with us, for the disclosures ahead will forever alter your gaze upon the infinite expanse above. Mysterious objects. The revelations began with shadows from the universe's cradle. In a sweeping survey of the distant cosmos, Webb's infrared eyes pierced through time, spotting 300 anomalous entities glowing with unnatural luminosity. These objects, candidates for the earliest galaxies, shine brighter than any prediction allowed, their light stretched across billions of years by the expanding void. Detected through sophisticated techniques that isolate their red-shifted signatures, they appear as if forged in a furnace of impossible energy, challenging the timeline of cosmic evolution. If confirmed, these luminous phantoms suggest galaxies formed with astonishing speed and mass mere hundreds of millions of years after the Big Bang, upending models that demand gradual assembly from primordial gas. The terrifying implication looms. Our understanding of dark matter's role in birthing structure may be fundamentally flawed. With spectra hinting at masses rivaling modern behemoths, these entities force a reckoning. Perhaps the universe's first lights ignited in ways we never imagined, fueled by unseen forces that accelerated creation beyond comprehension. Yet this was merely the prelude to Webb's onslaught. New moon. Webb's gaze then shifted closer to home, toward the icy giant Uranus, where it unveiled an hidden companion lurking in the shadows. Through prolonged exposures with its near-infrared camera, the telescope revealed a diminutive moon, scarcely 6 miles across, orbiting in a near-circular path amid the planet's ring system. This elusive body, invisible to previous probes, nestles between known satellites, its presence suggesting a dynamic history of formation and capture within the turbulent environment of Uranus's faint rings. The discovery illuminates the complexities of planetary systems, hinting that small moons like this may arise from debris disks, enduring gravitational tugs that shape their worlds. More chilling is the realization that our own solar neighborhood harbors secrets yet untold, with Webb's precision exposing fragments of ancient collisions or accretions that mirror processes across the galaxy. If such moons are commonplace, they could rewrite narratives of moon formation, implying a universe teeming with overlooked guardians, each a silent witness to the violent ballet of celestial mechanics. But Webb's lens was already turning outward again. Interstellar comet? Imagine a wanderer from beyond our stars, carrying echoes of distant births. Webb trained its spectrograph on an interstellar comet hurtling through our system. The third such visitor ever detected and uncovered compositions that defy solar norms. This icy nomad, outgassing as it nears the sun, revealed an unprecedented abundance of carbon dioxide relative to water, alongside traces of carbon monoxide and other volatiles. Such ratios suggest origins in a protoplanetary disk where temperatures favored carbon dioxide solidification, or perhaps prolonged exposure to cosmic radiation that altered its core. The unexpected chemistry implies this comet predates our Sun by billions of years, possibly hailing from the galaxy's ancient thick disk, a relic of primordial star formation. The implications cascade. If interstellar objects bear such diverse signatures, they could seed planets with exotic materials, influencing the emergence of life in ways we scarcely grasp. Webb's data paints a picture of a cosmos where comets act as messengers, bridging star systems with clues to universal chemistry, forcing us to question whether our own world's building blocks were unique or merely one variant in an infinite repertoire. And the telescope's discoveries grew even more profound: auroras on Neptune. Farther out in our solar realm, Webb captured ethereal glows on the enigmatic ice giant Neptune, revealing auroral displays of unprecedented brightness and complexity. These auroras, sparked by energetic particles interacting with the planet's magnetic field, illuminate atmospheric dynamics in ways never before observed, their infrared signatures piercing through hazy layers to expose swirling patterns of charged gases. Unlike Earth's familiar northern lights, Neptune's emissions hint at a tilted magnetic field, generating global phenomena, potentially driven by solar winds or internal heat sources. This breakthrough challenges models of outer planet magnetospheres, suggesting auroras could be more ubiquitous and varied than thought, even on worlds with tenuous atmospheres. The deeper unease arises from what these lights signify, a reminder that even familiar planets harbor active, evolving processes, possibly influencing subsurface oceans or atmospheric chemistry in life-conducive ways. If auroras signal hidden energies, they might point to undiscovered mechanisms across the universe where similar displays could mark habitable zones or alien weather systems. Webb, in unveiling this, has blurred the line between our backyard and the cosmic frontier. Habitable zones. Venturing to the nearest stellar neighbor, Webb provided compelling evidence for a gas giant orbiting the Sun-like star in the Alpha Centauri system, a world tantalizingly close yet profoundly alien. By masking the star's glare, the telescope isolated a faint signal, modeling an elliptical orbit that places this Saturn mass behemoth in a habitable zone equivalent. Though a gas giant, its presence in a binary system defies expectations of planetary stability, suggesting resilience amid gravitational chaos that could protect inner rocky worlds. The data, combining detections and non-detections, paints a picture of a planet surviving eons in a dance with two suns, its temperature akin to our own giants. This revelation shatters assumptions about planet formation in multiple star systems, implying that life-bearing setups might thrive in environments once deemed hostile. Philosophically, it beckons us to ponder: if the closest sun twin harbors such secrets, the galaxy may overflow with hidden planets, each a potential cradle for existence, urging humanity to gaze not just far, but near, where the familiar hides the extraordinary. Deep fields. In one of its most ambitious stares, Webb revisited a storied patch of sky, capturing the deepest mid-infrared view ever, unearthing thousands of faint galaxies shrouded in dust. This mosaic, born from exhaustive exposures, reveals reddish behemoths from the universe's toddler years, their light magnified by time's stretch to expose star-forming frenzy, invisible to prior eyes. Hundreds of these entities, compact and distant, date to under 1 billion years post-Big Bang, their dust-laden glows hinting at rapid maturation that mocks slow-build theories. The image's layers, blues for nearer realms, oranges for ancient dust, unfold a tapestry of cosmic history where old stars and embryonic galaxies intermingle in unexpected harmony. This disturbs the core of cosmology. If the early universe birthed such complexity so swiftly, perhaps dark energy or unknown physics accelerated the script, forcing revisions to the Big Bang's aftermath. Emotionally, it evokes awe at the universe's hidden depth, a void brimming with stories of creation, reminding us that every empty sky holds epochs waiting to be read. Exoplanet discovery, Webb's prowess extended to direct imaging of a nascent world, spotting a sub-Jovian planet nestled in the debris disk of a youthful star, 100 light-years distant. This Saturn-like body, lighter than any previously imaged, orbits amid gaseous rings, its faint infrared aura captured by blocking the star's brilliance. At just millions of years old, the system showcases planet formation in action, the planet carving gaps in the disk that echo our solar origins. This milestone amplifies detection capabilities tenfold, paving paths to smaller, Earth-like realms where life might stir. The implications ripple. If young disks harbor such worlds so readily, the cosmos could be rife with evolving systems, challenging timelines for habitability, and suggesting that planetary births are more efficient than modeled. Speculatively, it whispers of countless unseen cradles where chemistry brews toward complexity, bridging the gap between inert matter and sentient beings. Planet-forming disks. Further afield, Webb disclosed that protoplanetary disks endure far longer than anticipated, persisting around stars for tens of millions of years, their gaseous envelopes nurturing potential worlds. Observations of mature systems revealed lingering reservoirs of material, defying expectations of rapid dissipation by stellar winds or radiation. This longevity implies extended windows for planet assembly, allowing gas giants to accrete and rocky cores to form atmospheres under stable conditions. The finding disrupts evolutionary models, suggesting environmental factors like stellar activity or magnetic fields prolong disk life, perhaps enabling more diverse planetary architectures. In a broader sense, it heightens the odds of life, as prolonged formation phases could foster chemical richness conducive to biology. Webb's insight here evokes a universe patient in its craftsmanship, where time bends to permit the intricate dance of creation, leaving us to wonder if our own world's genesis was an anomaly or a universal norm. Ancient echoes. Amid these unveilings, Webb detected organic signatures in primordial clouds, polyaromatic hydrocarbons threading through galaxies billions of years old, amplified by gravitational lenses. These life precursor molecules, akin to earthly soot, yet vital for biochemistry, existed before stars fully ignited, implying the seeds of complexity were sown at dawn. This shatters notions of life's rarity, suggesting organic chemistry is woven into the fabric of existence, inevitable wherever matter coalesces. The philosophical weight is immense. If the building blocks permeated the early void, existence may echo across infinities, not as accident, but as destiny. But Webb's data hinted at stranger alignments, spectral duplications in lensed fields, resembling mirrored realities, where energy patterns synchronize across vast separations, teasing at multiversal overlaps or quantum echoes in space-time. Cosmic rhythms. In monitoring stellar nurseries, Webb captured vibrational anomalies from collapsing cores, low-frequency pulses that, when rendered, mimic ordered sequences rather than chaos. These heartbeats from birthing stars suggest hidden symmetries in gravitational collapse, perhaps influenced by dark matter webs or magnetic harmonies. The unsettling order raises queries. Could these be natural resonances, or do they encode deeper cosmic codes? Extending to dying systems, similar patterns emerge as if the universe sings its cycles, blurring lines between physics and poetry. Gravitational anomalies. Deeper analysis, aided by machine intelligence sifting Webb's trove, flagged voids, laced with gravitational twists, spirals of distortion without visible matter. These ghost lenses bend light in rhythmic ways, echoing dismissed artifacts from prior scopes now confirmed. Unclassifiable, they challenge general relativity, hinting at exotic matter or dimensional folds. The AI's reluctance to categorize amplifies the mystery, suggesting entities that pulse and migrate, reshaping space around them. Temporal anomalies. Most bewildering, Webb's mappings uncovered redshift inversions in clustered fields where distant light appears younger than near, defying expansion's arrow. This timefold implies space-time warps or simulation artifacts where chronology loops, questioning linearity itself. If real, it dismantles causality, proposing a cosmos where past and future entwine, leaving science on the precipice of paradigm collapse. Conclusion. Thus, we stand at the threshold of a remade reality, confronting a universe that defies the doctrines we held sacred. The James Webb Space Telescope was engineered to illuminate the obscure, to affirm the architecture of existence, to pierce the veil of ignorance. Instead, it has fractured the edifice of physics. From luminous harbingers of galactic infancy to concealed moons whispering solar secrets, from interstellar envoys laden with alien chemistries to auroral symphonies on distant worlds. Webb isn't merely observing, it is revolutionizing. And with artificial minds now deciphering its enigmas, unveiling gravitational specters and temporal enigmas that elude human grasp, the telescope transcends tool to become harbinger. Crafted to peer deeper than ever, what it discloses may exceed our capacity to fathom. If these initial glimpses have upended certainties, the horizons ahead might shatter illusions entirely. So reflect. Has Webb fractured science irrevocably or liberated it to soar? Share your thoughts below and subscribe to voyage further into this unraveling tapestry, for the next glimpse could redefine everything.